there in adopting in the implementation of the force method for the beam as well as for the frames. It will be say similar one. Only one difference will be there, and it is known to you that in case of beams, we are not considering the axial force. We are not considering the axial force. We do not calculate. Also, we do not consider the deformation in the axial direction. However, in case of frames, this axial force, this serves as the shear force for the column in case of frames. So only this is the difference. Otherwise, there is no difference in the application of the force method, whether it is a beam method or it is being applied for the solution of the numerical related to the beams, or it is or the frames. So also this is very useful. ये नजर आ रहे हैं सबको? CR slide नजर आ रही है?
Yes sir.
जी, thank you. So force method is very useful for solving the numericals involving statically indeterminate frames, which is having single story. It should be noted that force method can be applied to the simpler, simple geometry, simple frames like single story frame. And if there is a multi-story building, multi-story frame is there, then for that we need to use the slope deflection method. And this is due to the approach that is adopted, or the methodology that is adopted. That slope deflection method can handle the complicated solution, whereas this force method needs much more calculations if we apply this force method to the multi-story building. So it can easily apply to the single-story build structure, or which is having the usual geometry, and or if that is a gable frame. Gable frame का पता है ना? There are columns and the beam that may be tapered or that may be the straight line. This is known as gable frame, simple geometry. Now, the problems involving multi-story with higher degree of indeterminacy can be solved by slope deflection method or the moment distribution method. This will also be studied, and the stiffness method. So, a multi-story building can be solved using force method, but excessive computations are required. Excessive computations are required, and this becomes more cumbersome. The solution becomes more cumbersome. Now, the force method is similar to for the frames is similar to the force method for beams, except for the horizontal reaction. In case of beams, we are not considering, we do not analyze the horizontal reaction, but in case of frames, we consider the horizontal reactions as well, horizontal forces as well, because this will be acting as the shear force for the column. Also, it will be producing the moment for the column as well. So, external degree of indeterminacy, that is very as usual, that the total number of unknowns minus 3, this will be, and 3 is representing the number of equilibrium equations which are available. So it is regarding the frames. Now we will be solving the numerical. Everybody is requested to draw this figure. Everybody. Draw this figure, please. Have you drawn earlier? CR?
Yes, sir.
Okay. Now in this case, uh, the solution is given over there, 157.1. This is the horizontal reaction. This is the solution. How can we solve it? This will be shared with you. Just a little bit. No. This is the freehand sketch, irrespective of the dimensions. Dimensions are there, but these have not been drawn to the scale. It should be noted. Just you need to make your concept clear about the solution procedure. Now in this case, नजर आ रहा है भाई?
Yes, sir.
Okay. Now in this case, this is 40 kilonewton per meter. This is 5 meter, and the horizontal segment is 5, 10, and 5. This 40 kilonewton per meter. This is spanning for 10 meters. EI is constant. A, B, C, D, and the intermediate points, those have been labeled as EF. Now you can see. Now this everybody must listen carefully. Solution is very simple. On the same lines as we have done earlier in for the solution of the numericals related to the beams. Simple. Once again, if you are having any ambiguity, that can also be made that may be clarified in this topic as well. Now EI is kept constant. Now this structure can be broken into some other structures. Now in this case, you can see this is in 4 reactions are there, and so 4 minus 3 1. So degree of indeterminacy, that is 1. So it means to analyze this structure, I need 4 equations. 3 equations of equilibrium, those are already available with us. So one extra equation is needed, and where from that can be obtained, that will be obtained from the compatibility condition. And what is compatibility condition? I have told you that compatibility is the continuity at any support, at any joint, that is continuity. That it means it is in contact with this support. This is the compatibility. So it means that it should remain in contact with this support. This is compatibility. Now this can be, for the solution of this numerical, this can be broken into 2 parts. One will be the primary structure. I have told you now there I have taken the horizontal force as redundant. Horizontal force as redundant. Okay? Horizontal force as redundant. And if this is taken as redundant, this will be separated, and this will the removal of this horizontal reaction, this will render this support roller support. This will render this hinge into roller support. Now I have this roller support, okay, plus one redundant is acting over there. So in this condition, if I sum up these 2 structures under the concept of law of principle of superposition, then it will be equal to the original structure. Now in this case, as we have adopted the approach for the beams, I have taken the redundant in this direction, so I will have to show the displacement in the same direction. Now, under the effect of this 40 kilonewton, there may be some sort of displacement in the horizontal direction because this is roller support. I have considered it to be delta DH. It means this is the displacement at point D in the horizontal direction. this is due to the actual applied load, right? Plus this will be the applied, this will be the redundant force I have also applied in the same direction. Intentionally, this has been applied in the horizontal direction. Now, the ultimate requirement is that the summation of these two displacements must be zero. This is delta dH and this is delta dash dH. This is delta dH under the effect of this actual loading and under the effect of this redundant. So both the summation of these two must be zero. Must be zero means this member, this vertical limb must be in contact with the support. This is our compatibility. Now, considering this compatibility condition, I can develop the equation. And what is that one? Delta dH plus delta dash dH must be zero. So delta dH plus delta dash dH must be 0 is equal to 0. Now delta dH plus, now this is delta, and why both are positive? Because both have been given the displacement in the rightward direction, in the same direction. So I have taken both to be positive. So this is indicating that this is the displacement at point D in the horizontal direction, plus if you remember the stiffness, definition of the stiffness or the flexibility, then you might be knowing it, that this will be equal to this displacement or the deformation will be equal to the flexibility multiplied by the force. Flexibility multiplied by the force, you might be remembering. Remember CR, is it okay?
Yes, sir.
Okay. So HD, this is the redundant. It will be multiplied with the unit deformation. Deformation against unit force. This is the what it is. It indicates this is deflection or displacement at point D in the horizontal direction due to force that has been applied at D in the horizontal direction. This is the description of this subscript. So now, if I solve this very simple, if I simplify this expression, then HD will be equal to minus delta DH over this one. Now you can see abruptly, you can see that this is a negative sign. It indicates that the direction for the HD that has been taken wrongly. It should have been in the leftward direction. It should have been applied in the leftward direction. Then the summation would be 0. So intentionally I have applied it in the rightward direction just to make you very clear about the choice of the direction, that it is arbitrary and it will be depending totally upon the result, and the result will specify whether you have chosen the right direction or the wrong direction. So it will make no difference. So this will be this one. Now to have this flexibility value, I need to apply at the same location. I need to apply unit force in the same direction as I have made this one. So unit force has been applied over there, 1. So and accordingly, I will look into the effect of this HD, this one, and this 40 kilonewton per meter, and then unit load method that will be applied. Now in this case, first of all, I need moment, m value. You know it, that deflection is equal to integral sign 0 to L m capital into small m into dx. Is it clear to everybody? Is it clear to everybody? Abdul Hasib? Abdul Hasib?
Yes, sir.
Am I right?
Yes, sir.
Is it okay?
Yes, sir.
Hani, Engineer Bilal Mirza.
Yes, sir.
Bilal?
Yes,
Okay.
sir.
Thank you, Ji. Ubeb Hassan. Ubeb.
Yes, sir.
Shabash beta, shabash. Good. Fariha.
Yes, sir.
Okay. So, so if I now this is the primary structure. What is that? What are the characteristics of the primary structure? Characteristics are two in numbers. It should be determinate and it should be stable. Now this deformation, this has been shown just for our analysis purpose. Otherwise, in the real structure, there is no deformation or the displacement. Okay? So this is we have shown that this may be the deformation, but this has been closed, this has been nullified, counteracted by this reaction. So just for the analysis purpose, that it is stable. It is not unstable. You can see this is a hinge, this is roller support, this is stable. और दूसरा ये है कि this is determinate. ठीक है? So these are the two primary characteristics of the primary structure. Now, as far as the solution procedure is concerned, this one, everybody is required to keep the figure with him and see and follow my words. Whatsoever I speak, it should be followed, please, everybody. So in this case, you know that capital M, small m, 0 to L into dx, this gives you the deformation, deflection, displacement. This is a general expression. Now, what will we do? We will, on the same lines as we have done for the beams, we will divide the whole structure into different segments. You can see one segment is AB. Wherever there is the change in load, wherever is the change in orientation of the member, that should be separated. Now this is vertical column, one segment. Now there is a change, load is changing, means there is no load, but over there it starts. So BE, then EF, then FC, and then CD. Now all these segments will be considered, and you will be looking for the effect of this 40 kilonewton and for this HD for unit load, and then you will be multiplying capital M and small m to calculate the deformation or the displacement. So first of all, you see that when I solve this determinate structure, primary structure, 40 kilonewton is the load, and it is equidistant from the both supports A or D से, मतलब है इधर से भी 5 है, इधर से भी 5 है. So 40 into 10, this is 40 into 10, 400. 400 is the total load which is acting downward. It will be counteracted by the supports equally, 200 and 200. Now, if I consider AB, now it will have no effect. And if I consider A as origin, then this 200 kilonewton, it is passing through this joint. It will be having no effect on to produce any movement because this is passing through the joint. So its effect will be zero as far as movement is concerned. Similarly, if I consider BE, okay, BE, and if I consider B as origin, then its effect will come on to this one. So 200 into X, 200 into X, 200 into X, because 5 is changing. 1 मीटर पे कुछ और होगा, 2 and 2 मीटर पे कुछ और होगा, 5 पे कुछ और होगा. And so I can see the first one is 0, second one BE is 200 into 5, Now I see that under the effect of this force, it is producing sag inward, sag inward. In general, conventionally, if the sag is inward, then it is taken to be positive. It is considered to be positive. So we see what is written over there. This one, you can see that AB is A 0 to 5. It is EI is constant. I have taken it to be 1. Moment is 0 for the vertical limb. I have explained it. For BE, that small part, small segment, its length is 5, and this is taken to be 200 into X. Is it okay? CR?
Yes, sir.
और ये आप में से GR कौन है? GR क्या नाम है उसका भाई? GR
Sir Minahil Munir.
नहीं है यार, नहीं है. ओके, चले. तो ये कौन है? हमामा समझ आ रही है आपको? हमामा.
Yes, sir.
Okay. So this is for the portion BE. Then for EF, you can see this is written over there. How this can be calculated for portion EF. For EF, if I take origin at E, okay, now this 200 is passing through this limb, and it is acting at this in the form of shear force. Now this force into this is 200 into 5. This is the absolute value because origin is this one, and I will be considering the absolute value. So it will be 5 plus x. Variable is x. In this part, in this distance E to F, this is varying, so it will be in the form of x. So 200 into 5 plus x. ठीक है? If I say x is at up to this distance, then this is 40 kilonewton, which is acting downward in this portion. So it will be 40 into x. This is the resulting force for this part, and then it will be acting in the middle. So it will be taken to be x by 2. 40 into x by 2. So it comes out to be 205 plus x minus, because it is producing hog inward. It is producing hog inward. So 40 into x by 2. So it comes out to be 1200x minus 20x square. Is it okay? CR?
Yes, sir.
Mama?
Yes, sir.
Zunaira? Zunaira? जुनैरा, मैं तुम्हें रिमूव करने लगा था, तो ये मैंने इसी तरीके से सरप्राइजिंगली मैंने बोलना है, तो इसलिए मैंने कहा कि हर बच्चा जो है वो अटेंटिव होके बैठे, और मुझे बड़ी खुशी होगी कि आप लोग मुझसे सवाल करें, क्योंकि ये आपकी जिम्मेदारी है. जब तक आपको क्लियर नहीं होता तो, और अगर क्लियर है तो फिर आप अच्छा रिस्पॉन्ड करें मुझे और अटेंटिव रहें. Thank you. Okay. So this will be the moment. Now in this case you can see EF. This is 200. वही चीज है जो पहले मैंने आपको बताई. फिर then is CD and CF. CD CF जो है ये D और C लिया हुआ है. पहले CD देखते हैं ये CD में क्या है. CD में C लिया हुआ है. CD ये वाला है CD, इसमें C लिया हुआ है. तो इसमें आप देखें कि if I take C as the क्या लिया हुआ है, सी डी में डी लिया हुआ है, सी डी में डी लिया हुआ है, सी डी में डी जो है ओरिजिन, क्योंकि अगर सी लें तो वो चेंज हो जाएगा सारा कुछ। तो सी डी में ये डी जो है ओरिजिन है, origin has been taken at D. Now this 200 kilonewton is passing through this joint, so it will be having no effect on to produce the moment for this CD part, CD segment. So its effect will be zero. Its effect will be zero. So the same is written over there. You can see it, this one, that it is written as 0. Then comes the CF, and C is the origin, 200x लिखा हुआ है, तो CF में C जो है वो origin है, CF में C origin है। तो इसमें आप देखें कि you can see that 200 kilonewton, this is acting, this is passing through this is the line of action of this force, and this will be creating a moment, and it is producing the sag. So it will be taken to be positive in the upward direction. So this is 200 into x, and x varies from 0 to 5, from C to F. So it comes out to be C to F. ठीक है? So it comes out to be 200x. ठीक है जी? Now, then this is the capital. Capital M means the moment which is moment produced in each and every segment of the structure due to the actual loading. M is the moment produced in each and every limb of the structure due to actual loading. Now, then comes MDH, small, MDH, and it will depend on M, small m moment. It represents that you will be applying the unit load at point D in horizontal direction, and you will look into the effect in terms of moment. You will look into its effect in terms of moment for every segment. Now you can see, first of all, it is x, then 5. We see, first of all, it is x. You can see when you will be applying the load in the horizontal direction of 1 kilonewton unit load, then its line of action is this one, the same one. Line of action is this one. Under the effect of this one, it will be having the effect of in the form of moment. Now, under its effect, there will be a moment in the counterclockwise direction. ठीक है? Counterclockwise direction. Now, I told you that it can be taken to be positive or negative. Same nomenclature approach can be adopted and should be adopted, but it should be same for one structure. Now this is unit load. I have taken it to be positive, counterclockwise moment that has been taken to be positive, and if you take it to be negative, then all sort of forces which are creating the hog inside, those should be considered to be negative. Over there, intentionally I have chosen the different approach. Over there, it was tension inside, positive, and over there, I have considered counterclockwise moment to be positive, and it will be depending upon your choice. So you can see x is varying from A to B, means 5 meter. So 1 multiplied with x will be the moment due to this unit force. Similarly, if I talk about BE, then its effect will be transferred at point B, because B is the origin. Its effect will be transferred over there in terms of moment, in the form of moment, because 1 into absolute value of 5, this is 5, absolute value, because we are not considering its change in the distance for BE, for BE. This is of no interest for PE. So 1 into 5. So 5 will be acting at point B in the form of a moment, and it will be acting in the form of moment, and it is taken to be positive. If I consider it to be counterclockwise as positive, so it will be 5. Similarly, if I talk about EF, and E is the origin, then once again it will be acting in the form of moment, and it will be 5. It will be positive even for EF. Now see what happens over there. As you can see, it is X for the first vertical limb, then 5, then 5, and this is for the vertical limb CD, similar to this one, X, and this will be 5. Now when you will be multiplying these two, as I have shown you, displayed it over there, M capital, small m, 0 to L. This is giving you the displacement. On the same lines, only one displacement is needed as far as the actual structure is concerned, primary structure is concerned, actual loading is concerned. This will be delta DH, and if you multiply M into M, and in the then you need to apply the limit, and over there it will be integrated. There will be dx over there. Then M into M for the first one, you can see it is 0. It is will be multiplied, it will become 0. Then you multiply this one with this one, it comes out to be 1000. 1000x, 1000x square by 2, it is 0 to 5, so it comes out to be this one. Similarly, if you multiply this with this one, it comes out to be this one. Multiply this one with this one, it comes out to be this one. Or in dono, if you multiply these two terms and you apply the limit of 0 to 5, then you will ultimately be getting this value of 12,500. Okay? Am I right, Freya?
Yes, sir.
Ayan? Ayan?
Yes, sir.
Shabash. Well done. Hamza beta. Hamza. Thank you जी. ये HB405304 ये जो सीक्रेट सर्विस का कोई ISI का जो है वो बड़ा क्या है?
हसन नाम है हसन.
हसन आगे B.
Yes sir, हसन but.
हसन बाकिब.
Yes sir.
अच्छा. और नवीद अब्बास.
Yes sir.
थैंक यू जी. सो इज इट क्लियर? ये मेथड आपको क्लियर हो गया? जो समझ आ रही है?
Yes, sir.
Anybody, if you face any difficulty that can be pointed out, please. Okay. So to find out the flexibility, you will be squaring it. You will square it, M square. In place of capital M, there will be M, and this is also unit. This is also unit due to unit force, so it will be M square as is given over there. Delta AB or jaisa bhi hai. So it will come out to be X square. It will come out to be 25 dx. So you will be fine. You will be getting if you apply the limit, then you will be getting 41. This one, this one, and this one. So then you will sum all the displacements. You will also sum up all the unit flexibility displacements, and then all these values should be put at their relevant places. Then you will be getting HD equal to 157. This is minus, and minus indicates that the direction that was chosen, that was not right. It should have been directed leftward. Now, after you have obtained this horizontal force, if you have obtained this horizontal force, then the whole structure that at this moment, the whole structure has become determinate. Horizontal force is 157, vertical force is 200, 200. Okay? So it is this one. It will also be directed rightward at point A. At point A, it will be 157. Rightward at point D, it will be leftward. So it has become determinate. The it and the whole structure has been analyzed. The whole structure has been analyzed. Now, after this, the ultimate requirement is to draw the shear force and bending moment diagram. And you might have gone through the procedure for drawing the shear force and bending moment diagram in ESA when you were addressing the determinate frames. Have you done it earlier in your ESA?
सर अलग अलग जो हमारे है ना इसके मेंबर्स उनके लिए हमने ड्रा की थी।
हाँ जी वही जब आप वो कर लें ना, जब आप वो कर लें फिर उसको आप कंबाइन कर दें, ठीक है। तो ये अंडरस्टूड है क्योंकि ये मतलब आपको पता होना चाहिए कि किस तरीके से ये हमने ड्रा करना। तो शेयर फोर्स और बेंडिंग मोमेंट डायग्राम जो है वो आपने ड्रा करनी है। एंड वंस यू हैव analyze the structure and you have come up with the horizontal vertical forces as well as the moment, then if that is applicable in case of the fixed support, then you need to draw the shear force bending moment diagrams and axial force diagram for all the elements, for all the segments. ठीक है जी?
Yes sir.
Okay. Now once again, so this is regarding the this numerical. Now there will be another now there is another numerical. You can see it. Analyze the given frame. Is it clear? Or another?
Yes sir.
So it will also be this is being displayed in front of you. Now you can see that this is a structure which is loaded with 96 and 48 kilonewton, and both are fixed supports. And you can see this is 5 meter and this is 7.5 meters. So you need to draw it, please, along with the result as well. Everybody is requested to draw it. हाँ जी, ड्रा कर लिया जनाब?
Yes, sir.
Okay जी. So I will be sharing the solution of this numerical. This one. Now you can see in this case 96 kilonewton is the vertical force, 8 kilonewton 40, this is 48 I think, 48 था ना?
Yes, sir. Sir, वो अभी आपका solution नजर नहीं आ रहा.
अच्छा आ जाएगा. हाँ बता देना जिस वक्त आ जाए. आया? हाँ जी सिया. सॉरी
सर मेरे पास तो अभी तक नहीं आ रहा.
आ रहा है?
No, sir.
दूसरों को भी नहीं आ रहा भाई?
नो सर नहीं नजर
नो
आ
सर, नहीं नजर आ रहा सर.
अच्छा हाँ जी आ रहा है नजर?
No, sir.
जी नहीं यार.
नो सर.
सिस्टम में कुछ ये हाँ जी आप आ रहे हैं?
यस सर.
अब आ गया?
Yes, sir.
चलिए ठीक हो गया. ये जो है दिस इज 48 किलो न्यूटन. प्लीज सी carefully. This is 48 not 8. 48. This is 96. After all corrections this will be shared with you. I will be sending all these slides after making the corrections. So in this case you can see this both supports are rigid. Fixed supports. Fixed supports, it means is 3 and 3 6 minus 3 3 is the degree of indeterminacy. It means I need 3 compatibility equations to solve this structure. So I can do it by making this structure into different types of structures. Like this is the it will be equal to this primary structure plus horizontal force in this direction, redundant, plus vertical force in this direction, plus moment at this location. So this plus this plus this plus this all will result in the actual structure. So under the concept of law of superposition, this can be broken into different structures. So this is primary structure, and you know that this is stable. You can see this is stable. ये overhanging portion बन गया. This is stable, and also this is determinate. So these are the two primary requirements or the characteristics of the primary structure. Now we will be considering the deformation or the displacements in the same directions in which we have considered the redundant forces. Now I have considered horizontal force as redundant, so I will be considering the displacement in the horizontal direction. Vertical force as redundant, so vertical displacement. Similarly, moment, so rotation will be the that will be required. Angular rotation, deformation that will be required. So considering HD, VD, and MD as redundant, EI has been considered to be constant. It means it will be, if it is I, it is 2I, it is I, it will be 1, it will be 2, and it will be 1. Are you getting it?
Yes, sir.
So considering the compatibility conditions, in the horizontal direction, and certainly if you apply, because all these three forces, horizontal, vertical, and the moment, all these three forces are acting at joint D simultaneously. All these three forces are acting simultaneously. So we will be segregating their effect. So due to the horizontal force, redundant force, horizontal force, HD, due to horizontal force, there will be the horizontal displacement, vertical displacement, and the rotation, angular rotation. Similarly, due to the vertical force, there will be horizontal displacement, vertical displacement, and the rotational displacement. Similarly, due to moment, there will be the horizontal displacement, vertical, and rotational displacement. All these will be there, applicable and applied simultaneously. So if I consider the point D in the horizontal direction, to consider the this is giving you the sum of all horizontal displacements due to different forces, due to applied loading, actual loading, this one 96 or 48, this is 48, please correct it, 48, this is 96. So under the effect of this 96 and 48, there will be displacement in the horizontal direction. Under the effect of horizontal force, there will be horizontal displacement. Under the effect of vertical loading, vertical redundant, there will be horizontal displacement. Whatsoever is, whether it is very minute, at minute level and ignorable, but you will be considering it. So there will be horizontal displacement due to vertical load. There will be horizontal displacement due to the moment. All these will be summed up, and summation must be 0 because it is fixed. It is not moving in the horizontal direction. So all sort of effects, all sort of displacement in the horizontal direction due to any force, there must be 0. Similarly, the vertical displacement, total displacement should be 0, whether those vertical displacement are due to 96 and 48, and horizontal redundant, vertical redundant, and the moment must be 0. Similarly, rotation should also be 0, whether it is due to the applied loading, due to horizontal force, the vertical, or the moment. Summation must be 0. So this is the compatibility condition. Means your member must remain in contact with the actual support. must remain in contact with the actual support. So this is known as compatibility condition. So if I consider in isolation the horizontal effect, horizontal displacement, horizontal direction, then delta dh, it is the displacement due to applied loading, actual loading, delta. This is the same nomenclature as we have done earlier. Delta displacement in the at point D in the horizontal direction due to applied actual loading, plus HD. If I have applied horizontal force, then it will be giving you the displacement. So it will be, it can be shown by HD into delta dh displacement unit due to unit load at point D in the horizontal direction, where unit load has been applied at D in the horizontal direction. Similarly, the displacement in the horizontal direction due to vertical loading. This is the displacement due to applied moment in the horizontal direction due to moment. Similar is the case with this one. Now, in this case, I have considered in the vertical direction. Now, this vertical direction that is minus, because it is moving downward. It will be depending upon in what direction you are applying the load. If you are applying in the downward direction, it will be considered to be negative. If you have applied it in the vertical direction upward, then you will consider it to be positive. It should be considered to be positive. Okay? Now, in this case, you can see now under the effect of 96 and 48, it is very apparent that this joint will be moving downward. This joint will be apparently moving downward. So it is taken to be negative. Now this is negative. Now this is showing you the displacement at point D in the vertical direction. And similarly, in the vertical direction due to HD, in the vertical direction due to VD dependent, and in the vertical direction due to MD. Similarly, the rotation in the rotational direction, this is the rotation due to applied loading, actual loading. This is the rotation due to HD, this is the rotation due to VD, and this is rotation due to MD. So these three conditions of equilibrium, compatibility conditions will be giving you the three equations, and these three equations will be solved simultaneously, and ultimately you will be getting all the relevant parameters. Now it should also be noted, when you are solving any frame structure, and it should be known to you and might be knowing, you might be knowing it, that when you analyze this structure, it is basic requirement that three conditions are necessary to be fulfilled for the analysis of the structure. At every joint, equilibrium should be maintained. At every joint. If I talk about this joint, there should be the equilibrium. Okay? Now over there you can see. Similarly, if I talk about this joint, it should be in equilibrium. If I talk about this joint, it should be in equilibrium. Similarly, this in this. So at every joint, equilibrium. Within member, equilibrium. Whole structure, equilibrium. Now see that this is a member. This is 48. This is 48. Cancelled. खत्म हो गई. 96, 96 एक दूसरे को cancel हो गया. This is 504. ठीक है? And this is 288. If you see over there after this at this joint, you will see that effect of this one will come out to be 504. Or if you see the effect over there at this point, then effect of these forces will be 288. Now, if I consider this joint, you can see 288 in this direction, 288 in this direction. This is downward, this is upward. So balanced. Similarly, for this member, 96 downward, upward. And if I talk about the 288, 96 into this distance will be 288. Or if I reach over there, then 96 into this distance, 96 into this distance, and 288 will be equal to 0. So there is no moment which is acting at point at joint C. So in all the cases, when we are analyzing the structure, So there should be the equilibrium in all the cases, whether we are considering the joint, whether we are considering the member, whether we are considering the whole structure. That should be made made in equilibrium. Similar is the case with this one. This is also a an exemplary calculation, that if I apply this unit force, as I have taken HD as a redundant, and I will have to apply the unit load at the same location D in the horizontal direction, then this is 1, okay? And this is the line of action. This is 5, this is 3, and this is 4.5, and the remaining, this distance will be 2.5. So effect of this 1 will be in this direction, and its counteracting effect will be in this direction. So it will be 1 into 2.5. This is in this direction, and the counteracting effect will be 2.5. This is for the whole structure. And if I talk about the different segments of this structure, then you can see, you can take this segment in isolation. So it is 1 or 2.5, and it will, this is in this direction, it will be in this direction, this is in this direction, and it should have been in this direction. ये ऐसे होना चाहिए, ये इसमें गलत है, तो ये वाला जो है, this is 1, ये आ गया 2.5, sorry, this is ठीक है, ये 5 ठीक है, ये this is okay, 5, this is not 2.5, this is 5, this is okay. So it will be acting in this direction. 1 into 7.5 minus 2.5, it will be resulting force, moment will be 5 in this direction. So similarly, if you are considering the horizontal member, it will be, this is 5 in this direction, it should be in this direction, this is in this direction 1. So the joint is in equilibrium, this member is also in equilibrium. Similarly, this joint is in equilibrium, 1 in this direction, this in this direction, this is 5, this is 5. Similarly, this one, and this is 5. And if I take the effect of these two forces over there, it will be 0. So this is an exemplary analysis when you have applied the horizontal force. So is it clear, CR?
Yes, sir.
Any other person from the class? Any other?
सर एक्चुअली आप ना वो डिफ्लेक्शन की नोमेनक्लेचर हम तक एक्सप्लेन करते हैं, उसमें थोड़ी कंफ्यूजन है.
सॉरी
सर
अच्छा, ये आप लिख लें, ये ऐसे कर लें. ये मैंने एक लिख दिया, टेक इनसाइड बेंडिंग पॉजिटिव, बस इसी को फॉलो करो, बस बाकी छोड़ दें.
No sir, not this. Oh, sir, आपने लिखा नहीं था like moment at A due to horizontal loading at this. So वो explain कर दें जो word लिखे मैंने उस पे.
कहाँ पे?
सर ये जो क्वेश्चन में लिखा हुआ है ना deflection at DVDH.
अच्छा ये वाला, इसको मैं एक्सप्लेन कर दूं?
Yes sir.
अच्छा ठीक है बेटा, ठीक है. This is deflection at point D in the horizontal direction due to applied loading. ठीक है, due to applied loading. अच्छा, this is the flexibility, and flexibility is the deflection, या deformation, या displacement due to unit force. Now, what is this? This is flexibility at point D in the horizontal direction due to at point D when unit load is applied at point D in the horizontal direction. Again, this is flexibility means unit load की वजह से जो होता है. So flexibility या displacement at D in horizontal direction due to unit force at D in horizontal direction. ये है flexibility at point D due to in the horizontal direction due to unit load at D in vertical direction. Due to unit load in vertical direction. Due to unit load at D in vertical direction. क्योंकि ये vertical VD है. Similarly, this is the flexibility at point D in the horizontal direction when unit moment has been applied at point D. When unit moment has been applied at point D. क्यों भाई? You are
और सर
welcome.
ये
जी
सही
बेटा.
क्लियर हो गया और रोटेशनल डायरेक्शन के भी करते
जी
हैं
मैं रोटेशनल का भी बता देता हूँ, रोटेशनल का भी बता देता हूँ, इसका भी बता देता हूँ, बल्कि वर्टिकल का भी. This is acting downward. Apparently it will be under the effect, this effect or this effect. ये मतलब इसी तरह जाएगा और ये नीचे आएगा. अच्छा, this is the deflection at D in the vertical direction due to applied loading. Flexibility at D in vertical direction due to unit load at D in horizontal direction. Due to unit load in vertical direction due to unit moment at D. क्यों भाई? ठीक है?
यस सर
ठीक है, क्लियर? आर यू सेटिस्फाइड?
यस सर ये हो गया ये नीचे जो रोटेशनल
जी
डायरेक्शन
बेटा मैं उधर आ रहा हूँ, मैं यही तो है सबको, मैं तो और ज्यादा इसको एक्सप्लेन कर रहा हूँ, इसको डिस्क्राइब कर रहा हूँ ताकि अगर किसी और को भी कोई मसला तो वो भी क्लियर हो जाए. अच्छा अब नीचे आ जाए, अब नीचे आ जाए बेटा. थीटा डी, व्हाट इज दिस? दिस इज द रोटेशनल displacement at point D due to actual loading. ठीक है, हम उसी तरीके से रखेंगे, चीज वही रखेंगे. देन दिस इज ये नीचे आएगा, ये वाला ये यहाँ पे है, डेल्टा यहाँ पे है, इसको आप लिख लें. ये डेल्टा नीचे है, ये जो डेल्टा लिखा हुआ है ये नीचे आएगा क्योंकि ये रोटेशन है, ये डेल्टा नहीं है, ये रोटेशन है और रोटेशन ये. अच्छा, नाउ रोटेशनल डायरेक्शन. दिस इज द रोटेशन at point D when this is unit force has been applied at point D in the horizontal direction. It will be HD alpha D subscript ये डेल्टा सबस्क्रिप्ट D सबस्क्रिप्ट H सबस्क्रिप्ट. ठीक है अयान?
सर यही कंफ्यूजन थी क्योंकि ना वो साथ लिखा हुआ था ना तो
नहीं ये नीचे है बेटा, ये नीचे. शाबाश, थैंक यू. ये बेटा नीचे है, एवरीबॉडी शुड करेक्ट इट. ये मैं सारी चीजें जो है ना ये इसीलिए मैंने किसी को भी अभी नहीं किया, ये मैं हर एक को एक्सप्लेन कर रहा हूँ, तो ये मैं कर दूंगा. सो इट विल बी एच डी अल्फा डी डेल्टा डी एच. Similarly, it will be VD alpha D डेल्टा नीचे आएगा. क्यों जी? अयान बेटा ठीक है?
यस सर
शाबाश, अच्छी बात है. ये जो है डेल्टा नीचे आएगा, तो VD अल्फा, अब नीचे सब स्क्रिप्ट सारा ये आएगा, D delta dV. What it indicates? It states that it indicates rotation at point D due to unit force. This is delta, unit force at point D in the vertical direction. Then this is the rotation at point D due to unit moment at point D. हाँ जी.
ओके सर थैंक यू. बस यार
Any other one? Anyone else? Any other person? Everybody is welcome. Please come up. Thank you. So it means it is okay. Everything is okay. Now the solution, the next page is this one. This one. The same is this one. This is given over there. This is 24 और इसी को मैं ये आपको सब के साथ शेयर करूंगा. Now unit load This is in the vertical direction. This is the unit moment in any direction, and the result will dictate that the direction was right or wrongly chosen. So it will make no difference, and then its solution is this one. This is the solution of this numerical. If you are having with you the figure, then over there you can see that there is AE, BE. Are you having? क्यों भाई सियार ये आपके पास है ना फिगर सामने?
Yes, sir. Yes.
जो मैंने कहा था कि भाई इसको ड्रा कर लें और फिर ठीक है ना? है या नहीं है?
Yes, sir. Yes, sir. है.
इसमें घबराना नहीं है, जो चीज वो क्लियर बताना है कि नहीं है नहीं है, बस कोई बात नहीं, दोबारा ड्रा करवा देंगे। अयान है भाई बेटा?
जैसे ड्रॉ की हुई है।
ड्रॉ की हुई है ना, बस ठीक है, ओके। सो जस्ट कीप इट विद यू and just compare each and everything. Now I have segregated all the segments of this structure. AE, then is EB, the BE, then is BF, then is FC, and then it comes CD. And I have chosen arbitrarily, according to my own choice, the origin. Any point can be taken as origin. A, B, B, जो भी है, and this is the limit. This is EI, and you can see if there is 2I, it means it will be 2, because I has been taken to be constant, EI is taken to be constant, so I have taken as 1, and you also need to take it as 1. Then just keep it in front of you. What is moment? You can see that the solution, and you might have not drawn it, this one. You can see what is the moment for this one. Now you can see this is now you will see, you can see that it will be, if I talk about A to E, this is part AE, this is, and its a distance varies from 0 to 4.5, 0 to 4.5. Now over there, now you can see this 96 is passing through this one, so it will have no effect on the moment. 48 will be having some effect, and 504 will be having some effect. Now, due to 48, what will be the nature of the sagging or hogging? It will be this one. Inside it will be tension. Am I right? There will be sag due to 48. क्यों भाई? Ayan? Is it okay?
Yes, sir.
So 48 into x minus, why minus? It is producing hog inside. It is trying to bring it into inward. It is, this moment is trying to bring this limb inward. So there will be hogging inside. So it will be taken to be negative. So 48x minus 504. Is it okay? 48x minus 504. क्यों भाई सिया? अयान?
Yes, sir.
ठीक है?
Yes, sir.
Okay. So this is written over there, 48x minus 504. Now, on the same lines as we have done earlier, you will be calculating the moment for each and every segment of the structure, and you will be finding out the moment expression. Then unit load will be applied in the horizontal direction, and you will see, you will look into the moment for each and every part. Similarly, you will be applying unit load, unit force in the horizontal direction, unit force in the vertical direction, and unit moment at point D. Unit moment at point D. When you will be multiplying M, capital M, with any other, this one, and this one, multiplication of these two will be giving you delta DH. Multiplication of this and this will be giving you delta DV. Multiplication of M and small m theta, it will be giving you theta D. Am I right? Is it okay? Ayyam,
Yes, sir.
समझ आ रही है बात की?
Yes, sir.
Okay, thank you. Acha, everything is written over there. Now you can see this is delta DH, delta DV, theta D, और फिर if it is delta DH DH, इसका मतलब है कि इसको आप मल्टीप्लाई डबल करें, इसको डबल करें, इसको डबल करें, तो ये तीन आ जाएंगे, और फिर इन दोनों को मल्टीप्लाई करें, ये आ जाएगा, और इन दोनों को करेंगे तो ये आ जाएगा. And you will be calculating, this is a question mark, so ये आपने, you have to calculate yourself, and ultimately you will see that the result is this one, and you will be summing up all these values. All these values will be summed up. Ayan, is it okay?
सर
Yes. Yes, sir.
हाँ जी, welcome.
सर सीआर का नेट डिस्कनेक्ट हो गया, वो कह रहा है सर को बोलो कि इंटर कर दे.
अच्छा जी, दसो जी, जिसको मैंने चलो जी कर दिया. Okay जी, is it okay?
Yes, sir.
Okay. Now, just you will be putting the corresponding, the values at their corresponding places. यहाँ पर रखेंगे, यहाँ पर, यहाँ, ये. All these three equations will be simultaneously solved, and then you will be finding out this one. You can see कि ये सारी की सारी one equation, second and third, and then ultimately you will be getting HD, VD, and MD. All these forces will be calculated. Once you have done it, then you, in isolation, you can draw the shear force and bending moment diagram for each and every limb or segment of the structure. Is it okay to every person?
Yes, sir.
हाँ भाई, जवाद.
यस सर.
बेटा कोई ठीक है, समझ आ गई?
जी सर, आ गई है समझ.
और मेहदी खालिद.
Yes, sir. Yes.
थैंक यू जी. ओके जी. सालेहा नहीं. हाँ जी, बोलो. सालेहा नहीं. ये माइक चेक करो अपना. ओके जी. सो उसामा.
Yes, sir.
Thank you, thank you. So this is all regarding this numerical. Similarly, you can also, once again, you will be sharing something else. Now this is another numerical. You need to draw it. This one. Everybody must draw it. Anji, have you drawn it?
Yes, sir.
Okay. Now the solution of this numerical that is also given over there. This can also be shared with you. You can see it. This one. This one. Here. You can see this one. Now this is an inclined member. Now at this moment you must be known. You must know about the local and global coordinate system. Do you know it? Local and global. Local coordinate system and global coordinate system. Anybody? नहीं पता? CR?
सर एक तो वो हमारे पास जो जनरल होती है नोटेशन की हॉरिजॉन्टल और वर्टिकल, और एक जो हमें इधर अलग से गिवन है, इसको फिर हम उस हिसाब से कन्वर्ट कर लेंगे।
आप कौन है? अयान?
सर उज़ैर CR।
उज़ैर, अच्छा CR है। Yes, this is very simple that this XY, which is conventionally and generally taken, these are the direct system of axis. So this is global, XY. This is well established. And if I take, listen it carefully, if I take the axis along the orientation of the member, then it will be the local axis. What does it mean? If I take x-axis in this direction, everybody should listen it carefully. If I take x-axis along the axis of the member and y-axis perpendicular to this one, then it will be the local coordinate system. And if I consider in general this one, this will be the global coordinate system. Now this loading has been given in local, according to local coordinate system. Then in this case, it is required to find out, to draw the shear force and bending moment diagram. Now over here, you can consider the moment as redundant. Moment जो है वो आप इसको redundant ले सकते हैं, कोई और इसके अलावा कोई भी ऑप्शन अवेलेबल वो जो है ना वो horizontal reaction भी लिया जा सकता है, लेकिन यहाँ पर आपको ये कहा गया कि भाई आप अगर मोमेंट ले तो ये रिक्वायरमेंट है. So if you are considering MA as redundant, because you can see there are 3 forces and there is 1 force, so extra equation which is required, that is 1. So degree of indeterminacy is 1. So it can be broken into 2 structures. This is the primary structure. You can see this is hinge. ठीक है, ये हिंज है. और अगर आप हॉरिजॉन्टल फोर्स लेंगे तो कोई ऐसा सपोर्ट नहीं है जो हॉरिजॉन्टल को रिडंडेंट लेके तो वर्टिकल और रोटेशन को रिप्रेजेंट करे. अलबत्ता अगर मोमेंट को आप रिडंडेंट लेंगे तो ये आप इस फिक्स सपोर्ट को ये आप हिंज में तब्दील कर सकते हैं. समझ आ रही बात या नहीं आ रही? सीआर और एयान और जो बाकी हैं
सर आ रही है सर.
If you will be considering the horizontal force, then this will be removed. वो तो एक साइड पे होगी. No, the remaining leftover is moment and vertical force. There is no support that is having vertical reaction and the rotation. कोई ऐसी सपोर्ट नहीं है. इसलिए so at this location you will have to consider only moment. Only moment can be considered. When you will be isolating, you will be considering the moment as redundant. Then the structure will be rendered as a hinge support. Hinge support. and then this will become the determinate and it will become the stable structure. It should be noted. ठीक है? So under the its effect, this will there will be ये जो है ये अंदर bend होगा और ये हमारा primary structure है. This is the other one with the redundant, and the compatibility will be compatibility equation क्या होगी कि यहाँ पर जो ये deflection हो रही है इसकी वजह से theta a plus theta dash a due to this redundant summation must be zero. Summation must be zero. And if I simplify and write the relevant expression, it will be MA alpha A, or MA will be equal to theta A over alpha A. So this is my equation of compatibility, and just you need to have theta A and alpha A. And this is the primary structure. For this primary structure, you will have to find out the reactions at this location, at this location, and at this location. Now, this is 100. This is total 5. So total reaction will be to 500. Now 500, if this is to be converted in according to global axis, now this is acting in perpendicular to this local axis, perpendicular to local axis. This is local axis. This is x-axis and this is y-axis for local. Now this force, this is acting along the local axis. Now if I resolve it, then you will see this is given over there. Detail is given 500. If I resolve it into two components, according to the global axis, 300 force will be acting downward, 400 will be acting rightward. So in accordance with this one, considering this 400, solving this, I will be having 29.17, 300 and 370.83. These are the forces which are acting over there on the structure. And when I apply one unit moment at point D, at point A, then this moment will be counteracted by the reaction. This is in this direction, it will be in this direction. This is 1, and this is to be divided into couple, and this will be 1 by 12 because total distance is 8 plus this 4. So total distance is 12, so it will be 1 over 12, and this will also be 1 over 12. Now there are two portions, AC and CB.
Excuse me, sir.
हाँ जी.
सर वो सॉल्यूशन नजर नहीं आ रहा अगर आपने वो शो करवाया तो.
ये नजर नहीं आ रहा
सर? स्लाइड्स नजर आ रही हैं, अगर आपने वो सॉल्व्ड सॉल्यूशन शो करवा रहे हैं तो वो डिस्प्ले नहीं हो रहा.
नहीं, ये नहीं, ये सॉल्यूशन नहीं आ रहा आपको. ये जो पेज जो है जो मैंने हल किया हुआ है.
नहीं सर, वो नहीं आ रहा. स्लाइड्स ही अभी तक आ रही.
सॉरी. अच्छा, ओके. थैंक यू. मेरा ख्याल है वो बस ठीक है. थैंक यू. हाँ जी. तो ये तो यार वो पिछला सवाल भी मेरा ख्याल है नहीं हुआ होगा फिर. ये वाला ये भी ये अब हो रहा.
सर वो पहले नजर आ रहा था जब पिछला क्वेश्चन कर रहे थे.
अच्छा, ये आपने देख लिया. ये नजर आ रहा है पेज 27.
यस सर, अब नजर आ रहा है.
अच्छा, ये इसकी डिस्क्रिप्शन मेरा ख्याल है फिर आपने नहीं सुनी होगी. Now this is 100 pounds per foot. It is acting along the local axis, perpendicular to the local. This is x-axis and this is y-axis. This is considered to be, according to the orientation of the individual element, it is local axis, and this is the global axis. This is global axis. Now it can be subdivided into the primary structure plus the redundant force, with the structure with the redundant force. Now this is primary structure, and you can see that with the application of this moment, if I take the redundant force, it will then it will render this fixed support into the hinge support, and there if I take any other force, vertical force or horizontal force as redundant, then there is no support that is available with me that will be representing the moment and one force. Moment and one force. This is not possible. So I will be considering the moment as redundant, and remaining are the horizontal and vertical force, and this will be rendering this support into the hinge support. क्यों भाई, ठीक है? अब समझ आ रही है?
Yes, sir.
अच्छा. Similarly, if under the effect of this one, now if I have considered this moment as redundant, ठीक है, then rotation will also be there. So corresponding to this one, theta A plus the rotation due to this redundant, the summation of this and this its effect will be 0. And if I simplify this one, then MA will be equal to minus theta A over alpha AA. Is it okay? ठीक है?
Yes, sir.
Thank you. Acha, then you can see that this is 500, और फिर जब आप इसको ये इसको करेंगे रिजॉल्व करेंगे तो एक कंपोनेंट जो है वो तो ये 53.3 जो है ये इसका ये मतलब एंगल बनेगा, ये एंगल 53 है, ये भी एंगल 53 है, और ये तो ये एंगल जो है वो 36.8 बनेगा. जब ये एंगल बनेगा तो वो एंगल जो वो फोर्स जो कि हॉरिजॉन्टली एक्ट कर रही है वो बनेगी 400, और जो नीचे एक्ट कर रही है वो 300 बनेगी. और ये दिस इज गिवन ओवर देयर इन दिस फिगर. 300 डाउनवर्ड, दिस इज 400 राइटवर्ड. ये 28 पेज नजर आ रहा है?
Yes, sir.
Okay. So when you will be applying the unit moment, so it will be, this is unit moment and it will be counteracted by the reactions which will be created at the support. Then it will, if it is unit, then it will be distributed between the distance of 12 feet. So it will be 1 over 12, 1 over 12. So AC, यहाँ से यहाँ तक, then BC, this is, I have taken region this one, and for the BC it will be this one. The 0 to 8 यहाँ से यहाँ तक, 0 to 5 यहाँ से यहाँ तक, PI is constant, and you will see M, it is 29.17x. You can see it is passing through this A joint, it will have no effect, and under the effect of this 29 there will be movement in terms of 29.17 into x, and it is creating sag inside, so it will be taken to be positive. Similarly, in case of this one, now you can see 296.7 minus 50 x. ये this is क्या किया हुआ है ये this one. अब इसको ये इसका जो है वो आपने वो लेना है, इसका वो पॉइंट जिसकी वजह से ये इसको रिजॉल्व करना पड़ेगा. 370 को you will have to resolve this 370 into two components, because moment will be the perpendicular force. Movement will be produced by the perpendicular force. Okay, force into perpendicular distance. It is not giving any distance perpendicular to this one. इसके साथ इसके ऊपर perpendicular कोई है? कोई नहीं है जिसमें. तो 370 it will have to be resolved into along the local axis and along the global axis. Then it will be the part of the 370 which will be acting in this direction. In this direction is perpendicular to this one. It will be giving you the moment. So it will be 296.7. It will be acting this way, perpendicular to this underside of this beam into x. Okay? Because this will be moving upward and it will be creating tension inside, so it will be positive. And then the other part which will be acting, that will be 50x x square. This is due to this one 100 की वजह से जो है जो portion आप इसको लेंगे ये 100 into x by 2. ठीक है, समझ आ रही है या नहीं आ रही?
यस सर आ रही है
100, it will be resolved into components along and perpendicular to this beam. ठीक है, फिर वो मोमेंट इसके ऊपर एक्ट करेगा। इसी तरीके से ये 100 है तो ये 296 जो है ये इसके नीचे से एक्ट करेगा ऐसे करके, तो ये जो 296 इंटू एक्स इधर आएगा, एक्स इधर आएगा, तो ये 296x, क्योंकि ये पॉजिटिव है, क्यों क्योंकि ये ऊपर लेके जा रही है और ये सैग कर रहा है, और फिर ये आएगा माइनस, क्योंकि ये इनवर्ड लेके आ रहा है, ये जो 100 है यूडीएल ये अंदर वाली साइड में लेके आ रहा है, तो 100 इंटू एक्स बाई 2, तो इट विल बिकम इक्वल टू 50x स्क्वायर। 100 इंटू एक्स बाई 2, तो 2 के साथ 100 कट जाएगा तो 50 रह जाएगा, तो ये 50x स्क्वायर आएगा। तो similarly when you will be applying unit moment, then you will be getting these values, and then if you multiply these two values it will be giving you total theta A, and when you will be square this one it will be giving you alpha AA, and then when you will be putting the values then you will be getting MA, and if MA is obtained then you can find out horizontal and vertical HAs as well. ठीक है सीआर?
यस सर
Okay. Then there is another similar sort of question, and you have done it earlier. This is the support settlement. What will be the situation over there? क्यों भाई? That is given over there, and if I share it with you, the solution of this numerical, that is also given over there. Just I will be sharing it with you. और इसकी डिटेल में जाने से बेहतर है कि मैं आपको वो शेयर कर दूं जो उसका सॉल्यूशन है। सपोर्ट सेटलमेंट का जो सॉल्यूशन है वो मैं आपको दिखा दूं, ये वाला। What will be the condition? Then you have seen अगर CR या कोई भी बंदा, if I say listen carefully, if I say under the effect of this 40 kilonewton per meter, it is displaced, this is showing you the displacement by 15 millimeter in the horizontal direction. If I say under the effect of this 40, say it shows you displacement in the horizontal direction by 40 millimeter, then what will be the equation of compatibility?
सर वो जिधर हमने हॉरिजॉन्टल डिस्प्लेसमेंट का सम 0 किया उधर हम 40 कर देंगे।
शाबाश शाबाश। ये कौन है? उज़ैर?
यस सर।
हाँ जी, तो वेरी सिंपल, इसमें कोई नई साइंस नहीं है। जैसा whatsoever, this is the same procedure as you have done earlier in your beam numericals. If there was settlement, we have placed all the displacement equal to 0 in general, and if it is said that there will be displacement, it should be placed equal to displacement. Finish, nothing else. समझ आ गई बात? CR?
यस सर।
वो GR आई है? नहीं आई। ओके जी, तो और कोई? जुनैरा, आपको समझ आई है?
यस सर, यस।
ओके जी, और कोई? शाबाश, मेरा ख्याल में सारे ही अब आज बैठे हुए हैं। ठीक है, हरीमा समझ आई आपको?
Yes, sir.
ओके जी, सो ऑल दीज थिंग्स विल बी शेयर्ड विद यू, और ये आपको स्लाइडें भी दे दी जाएंगी, ये आप देख सकते हैं कि ये पहले इससे ये इंक्लाइंड जो था मेंबर, देन ये सपोर्ट सेटलमेंट है, इसके बाद ये हॉरिजॉन्टल फोर्स लगाई गई है, और इसी तरीके से ये इस तरह के मुख्तलिफ जो है न्यूमेरिकल्स हैं. All these sort of numericals, everybody, all these sort of numericals which are given, these are to be solved on your assignment register, everybody, and these are to be submitted. These will be submitted when you will be joining the university, and these will be submitted. These are also the practice numericals for your preparation for the exam. So if you are facing any difficulty, that can be pointed out. These will be shared with you. Some numericals have been solved, and the rest of the numericals are to be solved by yourself. Is it okay, CR?
Yes, sir.
ठीक है. So just download the attendance. ये डाउनलोड करो.
सर वो दोबारा से स्क्रीनशॉट ही दे देते हैं, क्योंकि सर डाउनलोड का ऑप्शन अभी भी मेरे पास नहीं आ रहा.
क्यों नहीं आ रहा? मैंने आपको प्रेजेंटर बना दिया.
लेकिन
अच्छा,
सर वो
चलो
डाउनलोड
करो. स्क्रीनशॉट जो है, दिस your Excel sheet must be supported with this one. This screenshot should be saved.
ओके सर.
ये इसकी स्क्रीनशॉट ले लो सब, ये अटेंडेंस के. अगर कोई कमी पेशी होती है तो ये जो है वो ये आपकी कमी पेशी होगी, और ये नहीं होनी चाहिए. किसी के साथ कोई कमी, कोई ज्यादती नहीं होगी. शाबाश. हाँ जी, हो गया, ले लिया.
यस सर.
सो जी इंशाल्लाह फिर मुलाकात होगी. We will meet inshallah next time. Stay blessed. Allah Hafiz, everybody. You can contact me whenever you feel any difficulty. So okay. We will meet next time. Inshallah. Assalamu alaikum.
मेरा एडवाइजर कौन है?